Okay, so here is your video for this coming week about spirometry, and I'm following right along with the slides that are posted. Unfortunately, my document camera can't toggle back and forth to the slides, so you're just going to have to read along with me with the slides, and know we're both looking at the same thing. So the first thing that we need to think about here with spirometry, slide number 1, are just the volumes. And these are the volumes that, had we been in class, you would have been measuring these volumes, air volumes going in and out of your lungs. So your tidal volume, this is how much you breathe in and out normally. So a normal respiratory cycle. So just, you're breathing like a normal person, you're not forcing anything in, you're not forcing anything out, you're just kind of breathing without thinking about it. That's your tidal volume. Now, if you think about it, when you take in a normal breath, you can force more air in on top of that. Like if you're like gonna, try to make a big noise or something, you breathe in really, really deep. The amount of air that you can force in on top of that tidal volume, that's your inspiratory reserve volume. Now, also, if you want to exhale everything out, and you can try it because nobody's around to hear you be weird, you can exhale below the normal amount of exhale. So you exhale normally and then just whoosh out a whole bunch more air. And that's your expiratory reserve volume. So that's what's under the tidal volume. Now, you cannot empty your lungs completely. About a liter, we're going to use a liter for this lab just to keep the math easy, but depending on your size and the size of your lungs and your lung capacities and all that, it could be a little bit more than that, but we'll just say a liter, and that's called the reserve volume. So that's how much air that you just can't get out no matter how hard you push. And we'll use the letters, the abbreviations for these. So TV is tidal volume, IRV is inspiratory reserve volume, ERV, expiratory reserve volume, and that reserve volume is the RV. Okay, so moving on to slide number 2. These next capacities are essentially the things that you would be calculating. So you measure the things from slide number 1, and you use those to calculate the things on slide number 2. So your inspiratory capacity, just think of these things just logically. Inspiratory capacity, how much you can inspire, how much air you can inhale totally. So how much air you breathe in a normal breath, plus how much air you could force in on top of that. So the tidal volume plus the inspiratory reserve volume. Expiratory capacity, how much you can expire, so how much you can exhale total. So normal exhale with your tidal volume plus the expiratory reserve volume. Functional residual capacity, this is what would be left in the lungs after a normal exhale. So you didn't force anything out, you just exhaled normally. So your residual volume that you can't get out no matter what you do, and then the expiratory reserve volume, which you could get out but you didn't in this case. The vital capacity, this would be all the moving volumes of air, everything that can go in and out. So the total amount that can go in and out. Think of it as everything but the reserve volume, because that's not moving. So just the things that are moving, the tidal volume, the inspiratory reserve volume, the expiratory reserve volume. Those are all the vital capacity. And your total lung capacity is just essentially the size of your lungs. How much air can move in and out plus what's left over. So everything added together. Tidal volume, inspiratory reserve volume, expiratory reserve volume, and the residual volume. So everything all together. So make sure that you know these equations. I'll give you, on the test, I'll give you some numbers for the things that you would have measured. So for your tidal volume, inspiratory reserve volume, all those sorts of things. You can't calculate them, you have to measure them. And for these on this second slide here, those are the things that you'll give me. So if you need to know these equations here, these 5 equations by heart. Now moving on to the third slide. So I'm going to draw kind of a representation of this. I'll have everything on it. It may not be exactly the same, but I just want you to be able to read this graph, which I have here. So here we've got how many liters. So I'll put an L on the side there. And then this is just time. So let's start here. Start at 1. So, oh no, let's start at 2. Sorry. So we're breathing in, we're just breathing normal. We'll breathe in, we'll breathe out. We'll breathe in, we'll breathe out. Nobody's pushing anything in or out too much. You might be able to guess what I'm drawing here. We're just breathing in and out normally. Now we're going to breathe in, And we're going to take a big old inhale up. And then we'll come back down. We're exhaling. Let's have one more normal breath. We'll exhale normally, and then we're going to push some more out. So we're exhaling as deep as we can. And then we'll come back to our normal in and out. Okay, so we can't see all that over there. There it is. Okay, so all those volumes we can get from this graph here. So you can guess probably what that is representing, right? It's, you know, breathing in and out normally, not forcing anything. That's just a normal respiratory cycle. So your tidal volume is this. Okay? In, out, in, out, in, out. So I'll just write it down here. Tidal volume equals 1 liter. So between 2 and 3. Okay, so we had a normal tidal volume, normal tidal breath, and then we inhaled a whole lot. So this is going to be, think about it, how much we forced in, how much we inspired on top of what we could inhale normally. That's the inspiratory reserve volume, but we measure from the top of the tidal volume to the top of the inspiratory reserve volume. So we go from here to here. That's the inspiratory reserve volume. So our IRV, that's from 3 to 4.5, so 1.5 liters. Same thing here, but exhale, so going in the different direction. How much we could force out after the tidal exhale. So we go from the bottom of a tidal breath, we could have done it here, because I had them in the same place, to the bottom of that exhale there. So this is the ERV. So that will be 1 liter, 2. Oops, put liters on everything. Okay, and our residual volume, that's how much air didn't move at all. Nothing moved in this bottom liter, so 1 liter. Okay, now on that graph, we can also think of those things that we would have calculated. So the vital capacity, the inspiratory capacity, functional residual capacity, and the total lung capacity. So let's do the easiest one first. Let's do the total lung capacity. That's how much air could move total in your lungs. So, oops, not that high. So from there all the way to the bottom. So total, not how much air can move, but because we're including the residual volume, how much air can move plus the residual volume, everything. This is your total lung capacity. So the total lung capacity is about 4.5 liters. Okay, now vital capacity. Vital capacity is everything that can move. So essentially, total lung capacity minus the residual volume. So from the bottom of the deepest exhale to the top of the steepest or deepest inhale, that's your vital capacity. We could exhale, we could inhale, all of those moving volumes, that's the vital capacity. So that's from 4.5 down to 1, so 3.5 liters. Okay, inspiratory capacity. That's how much we could inhale total. So let's go over here because we're getting a lot of lines over there. So how much total we can inhale. So from when we start to inhale, so we're starting to inhale here, to how much we could possibly inhale. So from the bottom of the tidal volume up to the top of the inspiratory reserve volume, that's the inspiratory capacity. So 2 to 4.5, that's 2.5 liters. And then the last thing, the functional residual capacity, that's how much air is left in your lungs after a normal tidal breath. So let's go back over here. So we exhaled normally, we could force out more, and then we got that residual volume. So from here down to here, that's the functional residual capacity. So from 2 to 0, that's easy, 2 liters. Okay, so there'll be a graph like this on the test, and you'll be given you know, this almost exact graph, maybe even the exact one that's on your slides, and you just need to know, if I ask you, I'm not going to ask you all of them, but I could pick any one of these and say, what is the tidal volume on this person? And you need to be able to calculate that. Okay, so it could be a graph very similar to this one or similar to the one that's on the slides. Now that just leaves us with one last slide to go, and that is slide number 4, and it has to do with the second part of the lab, which is where you're dealing with the forced expiratory volume, which is how much air you can exhale per second. So it's when you were doing it in lab, or if you were to have done it in lab, it would have been you're trying to time your expiratory reserve volume to last over 3 seconds. So it's a little bit tricky, just the logistics of that, but the idea behind it is that it's measuring how well you can exhale. So things that decrease your ability to exhale are chronic obstructive pulmonary diseases, things like asthma, emphysema. Those diseases are affecting your exhale. People think of asthma and things like that as making it harder to inhale, but actually it's making it harder to exhale, which means that if you can't exhale, you can't inhale. You don't have enough room left in your lungs. So that's what the issue with asthma is. It's the exhale, and any of those COPDs. So if you had one of those, it would cause your FEV to go down. Now, other types of lung diseases, like chronic restrictive pulmonary diseases, that's the second bullet point, they don't affect your FEV at all. They are going to decrease your vital capacity and your total lung capacity, so how much air you can fit in your lungs total, how much air you can move in and out of your lungs total, and they're not going to really do anything to the FEV. Now, you will be exhaling less than a person who had a normal lung situation, who didn't have a restrictive pulmonary disease, but proportionately it would be the same because you'd also be inhaling less at the same time. So examples of that would be silicosis, which is where you get silica dust in your lungs and it causes like a fibrosis sort of situation. Asbestosis, same idea, but with asbestos. You've probably all heard the commercial about mesothelioma that comes from asbestosis, that sort of thing. So there will be questions about that, just simply, you know, what's going to affect your FEV, what's going to affect your vital capacity, things like that. Okay, and that is it for spirometry. So watch this video, study these slides, do the questions on the back or in the back of your lab book associated with spirometry. Also do those questions associated with blood pressure and heart sounds. And then for the data for this one, I'm going to give you, actually I'm going to give you 2 sets of data here. One is for your blood pressure and your heart sounds, just the blood pressure part to figure out MAP, and then the other is for the spirometry. So for your blood pressure lab data, let's give you a good blood pressure. So we'll give you a 110/70 blood pressure. So use that to calculate your mean arterial pressure, which would be on the video from last week, and also the equation is in your lab book, so that's pretty easy to calculate. You probably already went over it in lecture too. For our spirometry data, so I'll give you the volumes that we would have measured, and you just use those volumes to fill out the data sheet on your lab book, in your lab book, and then use it to calculate those capacities, the inspiratory capacity, expiratory capacity, etc. All the things from slide 2. So I'll give you a tidal volume of 3 to give you good lungs, an inspiratory reserve volume of 1, an expiratory reserve volume of, let's say, 1.5, and then a residual volume of 1. And those would all be in liters. You can't see anymore. There you go. So those would all be in leaders. So use those, and I will have posted a sheet where you can input your data. I'll do that in a few minutes. So you can turn it in Blackboard, so there'll be a little link just like there was, and then you can get your points for these labs too. So these labs are going to count for more because you're not doing them in groups, so they'll count for a little bit more points. That way we end up having more points rather than just test-based points. So I want to try and get you more points with assignments and less points on tests, if that makes sense. So we'll have those, and I'll ask a couple of questions to go with them, and I'll just make it one big old assignment for both of these, and it'll be due Friday. So you have all week to do it. It'll help you study for the upcoming lab test, which will be, of course, online. And that's it. Email me if you have any questions. I might not be on email too much tomorrow, but I will be back on Monday for sure. Okay, that's it. Have a great weekend, guys. See ya.